This video provides instruction on how to solve a system of linear inequalities by graphing. So here's our system. Y is greater than or equal to 3x plus 2, and we have y is less than negative x minus 2. So our first step is we're going to take the first inequality, we'll change it to an equation, y equals 3x plus 2. And now we are going to graph that line. And remember, when we graph this line, since it's a greater than or equal to problem, we're going to use a solid line for this one. So this is in slope-intercept form. So we go to 0, 2. The slope is 3, so we're going to go up 1, 2, 3, right 1. Or from the y-intercept, we can go down 1, 2, 3, left 1. Down 1, 2, 3, left 1. Okay? And then I can draw my solid line. Okay. Now we have to figure out what side to shade. So we're going to do a test point, and we're going to shade the truth. And in our class, we teach students to test both sides just in case you make a mistake. A lot of times you'll catch that mistake if you get true, true, or if you get false, false, etc. So an easy point to test is 0, 0. So in this case, 0, 0 is located to the right of the blue line. So we're going to test 0, 0. You substitute into the original inequality. So we're going to go 0 greater than or equal to 3 times 0 plus 2. So then we get 0 is greater than or equal to 2. That is false. All right, so now we're going to test another point on the other side. Let's test like negative 2, 0. That's clearly on the left of the line. Again, it cannot be a point on the line. So negative 2, 0, we substitute that in. We're going to get 0 is greater than or equal to 3 times negative 2 plus 2. So we get 0 is greater than or equal to negative 6 plus 2 is negative 4. And that is true. Okay? So now we're going to shade to the true side, which is to the left of the line. So let's just do a light shading. I'm just going to do everything in horizontal markings for this one. All right. So now we're going to do the other line, the other inequality. So again, we're going to graph now the line y equals negative x minus 2. But this one is just a less than problem. So we're going to use a dashed line to graph this one. So we're going to go to 0, negative 2. And then we are going to have a slope as negative 1. So we're going to go up 1, left 1, up 1, left 1. Okay? Or we go down 1, right 1, down 1, right 1. And do not make a solid line, but we can make kind of a dash line here. There we go, dash line. Okay, same thing. We can test 0, 0 on this one. So if we test 0, 0, we get 0 is greater than, wrong one. 0 is less than negative times 0 is 0 minus 2. So 0 is less than negative 2. That is false. Okay, so let's test a point on the other side. So 0, 0 was above the green line. So let's take a point below the green line. How about 0, negative 4? So we're going to test 0, negative 4. All right, so substitute that into the inequality. Negative 4 less than 0 minus 2. So negative 4 is less than negative 2. That is true. So that means we're going to shade below the green line. So I'm going to do vertical shading here. Oh, I didn't want to use green. Let me change colors here. Let's go purple. All right, so vertical segments here below. And you'll start to see how I crisscross with my pink horizontal shading. Okay? The crisscross, that is the solution. So a lot of times on your paper, you want to make this a little darker so you can clearly see. So it's everything coming up to the dash line there, not including the dash line. It's everything on the line from this part going down, right? And then over here, right? And so then this section here is our solution. So you can check this. If you take any point from that double shaded section there, the section that's shaded in black here, it will be a true story for both inequalities. If you pick any point that's here in the unshaded region, it should be false for both. If you pick any in just the pink only shaded section, that will work for the first inequality, the one on top. If you pick anything down here, just the purple shaded region, that will be true for the bottom inequality, but false for the inequality above. All right, hope this helps. Thanks for watching.